think we're live. Let me just check. Make sure that we are indeed live. There we go. Twitch TV, SethGaleWeeks.com. Wow, things are really lagging. Okay. Looks like we are live. Cool. So, I've been playing around with this idea for a while to make a fourth variation. There's probably other languages like fourth, but essentially it's a stack-based language, and it goes left to right. You put your characters in, and it puts them all in the stack, and then you give your function, and then it takes, let's say you do 5, 4, plus. Plus is a function that takes the top two, adds them together, and then puts that result back on the stack. So I thought I would just implement something basic like that, just for basic arithmetic to start, and then see if we can, instead of doing it, had some ideas of, instead of doing it in reverse Polish notation, still being able to use infix operators, to saying 5 plus 4, but still doing it based on stack operations. So that's the idea. I just installed Bun, so I'm going to try doing this in TypeScript, and we're going to do Bun, let's see, Bun watch index.ts. Index.ts. Index. There we go. Alright. So, fortunately my computer is being really slow today, but we'll trudge along and hopefully it keeps up. Hoping the audio is working okay. So, okay. Let's give this a try. So, the goal eventually will be to do infix. So we'll do our test of infix, which will be a string of something like 1 plus 2 times 3, something like that. But for now, we're going to do RPN, and we're going to do, is that correct? Let's see if we got it correct. We're going to do, well, 2 times 3 would be, and then add it to the 1. So that would be correct in terms of precedence, but I'm not going to worry about precedence in this moment. So it's going to do the 1 plus 2 first, and then times the 3. So that would actually be 1 plus 2 first, and then do the 3, and then multiply them together. So these two should give us the same result once we implement the second one. Okay, so first we're going to do a tokenizer, and I'm going to be really simple with this. We're just going to say if there's a space between each one of them, then it's going to be a token. So we're going to say const tokenize, and that's just going to be a function that takes a string and splits on the space. There we go. Copilot helping us out here. So if we were to see console.log tokenize of infix. Let's give that a try. So there we go. There's our tokens. Very cool. Alright, so the next thing that we want to do is, now we've got to tokenize, we want to take each one of them and evaluate them. So we're going to do, I guess, so the cool thing about fourth, like usually after tokenizing, you would then parse, and then you would then also convert it to an AST, and then you would evaluate. But in this case, the parsing I think you can basically skip the parsing and the AST. You can basically just evaluate it. So you can just start evaluating it right away. So let's give that a try. We're just going to say, whoops, const evaluate. It's going to take a list of tokens. There we go. Excellent. Okay. So we're going to say evaluate RPN. And what that's going to do is we're going to take each one of those, and essentially we're going to, let's do this, I like it. For const token tokens, if tokens plus stack.push, stack.pop, stack.pop. I like it. Else if tokens stack.pop, else stack.push parse and token. That's amazing. I love how well of a job that did. It has one little squiggly line here. This type cannot be determined. How would we fix that? I think we can just say the return type of this. No, that wouldn't work. Stack would have to be well, really, I'm actually okay with it being a type of any. Okay, so long as I'm explicit with it, it's fine. So let's just do const, or I'll do console log evaluate and tokenize RPN, and we're expecting that to be, yeah, we're actually expecting it to be 9. It's pretty impressive what Copilot's doing here. So it is 9. Excellent. So that's basically the idea for doing it in reverse Polish notation. It's pretty simple. Of course, we're just doing numbers here, and this is a string, so figuring out that there are strings within that string would be more complicated. Basically, it'd be better to just read a file in. But instead, I'm just going to stick to the numbers. I'm going to now make a more functional version of this, where we're actually just going to kind of reduce over the string. So we're going to start with an empty stack, and we're going to say string dot, oops, that's not what I wanted. String dot reduce so I'm going to comment this out and see return hack plus stack.pop else if token is equal to So that's not quite what we want. But essentially we want to start off with a stack that is empty. So the initial condition will be an empty stack. And so at each point, if the token is a positive, is a plus, then we're going to take the first 2 items off the stack. So we essentially want the so the stack will be for now what we're going to do is we're just going to stick them all on the stack. Okay, and then we'll evaluate them later. So we'll just say hack we'll be a little bit more efficient with this. We'll just say ack dot push token, and then return ack. Now, since this is just a stack, we may as well rename it to stack here. Okay. And this is tokens, rather. Tokens, reduce, stack token, push token, type never. Okay. So it's saying undefined. Why is that? Argument of type string is not assignable to parameter of type never. Not sure. Okay, so why is that now saying undefined? Reduce takes in the function first, the initial value. So for all the tokens, we're going to take the token, push it to the stack, and then return the stack. Keep doing that. Why is that not liking that? Well, we'll try the more traditional way of doing that. Spread syntax requires iterable not to be null or undefined. Is it because it's not understanding the type of it? As any? Nope. Not to be null or undefined. Why is it null at the beginning? Or when is it null, I suppose? Console log stack token, I suppose. Oh, okay, I didn't return it either. Okay, here we are. Here we are. Oh, you know, I didn't return anything from here. Okay, that's what's going on. Okay, so let's just return that and then do, I think we were fine before. Stack.push token and then return stack. Okay, so there we go. So this is doing a reduce instead. We can even get rid of that. There we go. Okay, so now we got we're pushing all of them in there, but we don't really want to do that. So what we want to do is, depending on what it is, either push it or pop two of them off, and then so we'll say case, or switch rather, switch token case plus and close out that switch statement. We're going to do we're going to pop the two of them, add them together, and then push it back. So stack dot push stack pop. That should be fine. Case multiply, similar sort of thing, and then default stack push parse int, and at the end we'll return the stack. Okay, didn't like that. So what's going on? Well, I'm not breaking here, so I actually have to put in the break in each one of these. That's probably what's causing it. Okay, there you are. So that's the final one right there. Okay, so that's the idea. We reduce over it, we put something on the stack, and then we pop it off with the operations and do something with it. Now here's the idea. I wanna basically do this, but in order for me to do infix, I kind of need to know what the operator is supposed to do and what's already on the stack, and see if the things kind of line up. So here's the idea. We see the 1, we put it on the stack because it doesn't not a value. It's already a value, right? And it comes with a type. The type will be, we'll just say number, okay? And then it sees the plus operator, and the plus operator is a operator with a certain type. So 1 has a type. We'll do with this notation. 1 has a type of number. Okay. Plus has a type of number. Excellent. So it will see this function. This function will say, okay, I need a number. I see that I have a number. I'm going to apply that number first and essentially do partial application. I still need another number in order to give you a third number. So I'm not going to evaluate it yet, essentially. And then it sees the 2 and says, okay, now I have another number, and that number matches the stuff on the stack. So I'm going to apply that, and then that's going to give me the resulting number, and so on and so forth. So this even allows you to essentially put functions onto the stack that then get applied to the parameters. Instead of applying the functions, instead of taking the function and applying to the stack, you apply the number to a function that's on the stack, essentially. So that's the idea. Not sure if it'll work, but it's something I've been toying within my head for a while. So along with the actual thing that we put on the stack, we now essentially want to also put some information about that token. So if it's an integer, or if it parses to an integer, we're going to push well, at any one of these steps you may have to evaluate, right? Even if you push an integer to the stack, you may need to apply it to the function that's on the stack. So what we're going to do is we're going to take a look at I kind of want to see what the stack looks like at each one of these iterations. So we're going to console.log stack 1, 1, 2, 3, 3, 3, 9. Okay. I was kind of hoping that the top of the stack was at the head, but we're pushing it to the end, not to the beginning, obviously. We could change that. We could push down on the stack if we wanted to. I think the operation for that is stack.unshift or something. What happens if we do that? So instead we do that, we do stack unshift, and then here we do stack shift. Unshift? Unshift, right? Yeah, there we go. So it still gives the same result, but now the head of the array is like the last thing that we put on there. Okay, So there is a reason why I want to do that, and that's because we can very easily now destructure the first thing on the stack, because we're going to need access to that first thing. Now, it doesn't really matter, I just realized, because I thought you only need to look back one, but you may need to look back more than one, right? So theoretically, this evaluation model would still work on the RPN version. This should still both work, because the plus will look back 2 and see that they're both numbers and then evaluate to a number. Okay, so we'll stick with this for now. Okay, so let's take a look at our data structure. We want to push onto the stack the integer but along with its type. So we'll say that by default it's going to push parse integer. We're going to say value is parseInt and type is number. Okay. So now when we pop them off, we actually need to grab their values. Okay, didn't like that. Let's take a look at what's on the stack again along the way. Oh, okay. It pushed back, it didn't actually push the new type on. Okay. Okay. So what happened was it got as far as the first operation, and then this thing really should say value and then type as number, and then same thing there, value and type as number. Okay, so that's a stack along the ways, and then eventually get to the end. There we go, value 9, type number. Okay, so here's the idea. At any point, we need to, instead of just doing this operation, we need to check to see if the last thing in the stack matches the type of the operation we're trying to perform. Let me think about this. We want to check to see if so again, the type of plus is number, right? And so we need to check to see if the last thing on the stack is a number, or the last two. Let me think about this. So if we just look at the last one. So in infix version, we only want to look at the last one. In RPN version, we look at the last two, right? You want to go as far back as you can to match any number of parameters that you need. Okay. So in this case, when we apply 1 plus 2, 1 fills in the first one, 2 fills in the second one. If we were to do this one though, and we look backwards in the stack, 2 fills in the first one, 1 fills in the second one, if we were to evaluate in that order. I guess that should be fine. I don't know. It's something we can sort out in the future. But let's just get something simple working. We're gonna look back in the stack, and we're going to see if how do we do this evaluation here? I'm going to do a really naive code, but we can expand on this in the future. So stack.pop does actually, it modifies it, right? I think if I were to do console.log, we'll say r equals 1, 2, 3. Yeah, okay, so it actually modifies the stack, which is normally fine, but in this case we just kind of want to look ahead, right? So we want to look at the value without actually removing it. So if we did pop it off and its type matches again, we're going to be really naive with this. We're just going to say grab. I am going to switch this back to the unshift version. Unshift, and wherever we see pop, we're going to do shift. Okay. So now we're just going to say if we're going to say I'm trying to do some destructuring here. Top and second. If I do this though, top and second is equal to stack. I think destructuring leaves it undefined, right? It doesn't like throw anything. So what we're going to do is we're going to say if top.type is equal to number and second type is equal to number, then we're going to do this. Else if top.type is equal to so first situation is top is number, but and the second one is number. Apply them both. Second one is top is number, but the second one is not number. Then we're going to put on the stack a function. Yeah. So the value is going to be a function which takes the first thing off the stack, takes the thing off the stack. This has to grab the value off the stack. Okay, takes the value off the stack. The type of this guy would be so I need the value from it. I'm going to add it to the value there, and I actually want the type to be number, like that. Okay. Does that sound right? So if the top one is number, but the second one is not, then I essentially just want to put a function on the stack that will wait for me to get to the next value, and then we'll return. So this actually has to return back also a value of that, and its type will then finally be number. So I'm placing onto the stack a function that needs the number, type of number, let's see. Okay. Alright. So that handles the case where the top two are numbers or only the top one is. Fine. Else. Okay, so I guess the last one is the top. There's a bunch of different variations, but for now I think this will cover our cases here. So let's try doing more or less the same thing for the times multiplication. If they're both numbers, this actually should be and, I just realized. Both of these should be and. Do the same thing again. Top second is equal to stack. Oh, I just realized this is supposed to be const. Top second. This should also be const. Top second. Again, this is going to be function. And then otherwise, we're just going to place it on. So even this one is different, right? Even this one, if it's a value, we need to take a look at what's on the stack. So we're going to say top stack if top.type is a number, then so let's see what Copilot did first. unshift top value parse into type number. So what we actually want to do is if the top one is this function thing, which we really could have just done function, but in order for this to be scalable in the future, we essentially want to be matching against these type annotation stuff. But we'll probably do that in the future. So basically, if the top one's a function, then we want to grab the function, so we want to unshift, but we want to value stack dot shift value. Oh yeah, okay, that's right. Call the value with parseInt and then return the type as number. Is that what it gave me in the first place? Pretty much. But I also wanted that stack unshift bit. Or stack shift bit. Okay. Alright, so I've already declared things before with these, so I guess we'll do let again, probably much better ways of doing this. Top has already been declared. We can break these off into their own little tables here, or functions. We'll say const add we'll take in the stack and return back one of those things, right? So we'll let top second equals stack. I suppose we could just put that directly in here. We can say top second and we don't really want to be shifting around the stack directly in here anyway. Yeah, never mind that. Okay, let's just fix this issue here. So essentially the issue is that I keep reusing top and second. I can't be doing that. So what to do? We just want to peek at the first and second there. And I just wanted to kind of avoid we'll just replace all of wherever we see top there with stack 0, and then second will just be replaced with stack 1, and remove this bit, So what else am I missing here? We got lots of squigglies. but a lot of them are probably type errors. So the first one is expected colon but found semicolon. Let me actually just restart this so I have a clean slate. On line 13, expected colon but found got a semicolon. Okay, so I'm unshifting an object with a value that is a function where I'm destructuring the value and returning back. Okay, this has to be wrapped in parentheses. Same thing with this. Okay. Undefined is not an object evaluating stack 0 dot type. Okay. So I think we can do optional chaining. Hey, there we go. Okay, it's not giving us the right thing. It's not even getting very far either. Okay, so we've tokenized RPN. We have, okay, at some point it ended up just putting the number on the stack, it looks like. So where did I miss that? End up just putting the number directly on the stack. Let's console log the stack at each point. We'll do token and stack so that we can get a little bit better idea of what. Okay, so the token 1, the stack becomes value 1 type number. Token 2, stack becomes value 2 number, value 1 number. Token that becomes value 3 type number. Okay, no, that's right. Okay, then we see the 3. We have 3 number. Oh, okay. No, that was correct. Okay, it was just doing that bit at the bottom. There we are. So that's the correct one. So if I'm not mistaken, let's just replace it with infix. Okay, didn't like that. Undefined is not an object. Well, the grand reveal did not quite work. Let's see. Undefined is not an object. Line 11 and line 32. Did I miss a couple places? Yeah, I did. Sure did. Okay, value, not a number. Let's see what a stack looks like along the way. Console.log token. And we'll just do token stack like that. Okay. So starting off, we have 1, 2 plus what happened here? Token 1 stack, token 2 stack, token plus, and the stack get like blown out. Oh, okay, here we go. So 1, and we have the plus, there's a function, 1, but it still has a 1 on it. Why is that the case? Then we have 2. No, that's not right either. Token 2. I'm a little confused. Let's do that and clear out that. Okay. So let's see what we have again. First of all, token starts at 1, value 1 number. So second we hit the plus, the stack is still has the 1 on it. It shouldn't have the 1 on it anymore. So in the case of plus, essentially this says the stack it should have hit this case, right? Console log. No, here, let's do that. Okay. So the first time is 1, then plus, it's supposed to be doing this bit here. We have stack shift value plus the value and then type number. And that's the whole thing. At this point, after having done stack.shift, oh, because it didn't actually shift it yet. It will shift it. Haha, okay. Okay, so what we have to do is we have to actually have popped it off first and then, okay, so we do is const value call it pop. It's not the cleanest code at all, but it's just a little proof of concept at the moment. Okay, 1 plus is a function, 2 and immediately it's not a number. Oh, okay, interesting. So value at this point becomes an object of value. So what happened there? We saw the 2. We called the function. Oh, okay. We don't really want this to return back an object, do we? We want it to just be the function itself. Okay. I think we want to. Does that work? I don't know, actually, no. I think it does. Okay. Nope, still not happy. It is flat now, though. So 1, then we do plus, and then function, and it says value not a number already. So once it hits the 2, had 2 hits over here. Type is stack.type is number. Value should be stack shift value. Call it with %. So we're gonna do console.log stack 0 value. Yeah, sure. Pretty happy with what that would do. Non-number. Okay. It is a function. Okay. It's a function that seems to return I should be able to just use a parentheses. I don't see why that was wrong. Yeah, I don't think that was a problem. The parentheses should be fine. Oops, I think I possibly am killing my video. Let me see. Oh, interesting. Video seems to still be going at the moment. See if it dies at it soon. Keep looking at that. Okay, so pop plus value I'd like to know what value is, so let's expand this function here. We'll do a return, and we'll do a console log value and pop. Value is undefined, and pop is 1. Value is undefined. As top. Not as, what is it? If you want the, I don't even remember. I'm just going to say top and top dot value. Top and pop. Pop is 1. Why is pop only 1 and no value on it? Why is it that it's not the value that I'm receiving? Because I'm already pulling the value off of there. Okay. So I think we can just essentially say do that. there it is. Okay. Remove these console logs, and don't think we need that bit there either. Hey, there we are. Cool, cool, cool. Where else am I doing with console log? Right there. Okay. So we essentially have a stack-based thing that allows us to do infix operators. Now you can do a mix of these. We could now do 1, 2 plus, they'll add them together, and then times 3. And that should still work. Here we are. Not the most flexible system. And in order for this to be more full-fledged, we would need assignment and being able to make your own functions, and those functions should be able to I was thinking if you make your own function, your functions would be called probably with I guess it shouldn't matter, right? Again, you can, because it's just doing stack operations, it doesn't really matter where you put your function, so long as the function has a type. You can put it infix, you could put it prefix, you could put it postfix. Of course, we didn't actually implement prefix, right? But theoretically, you could push the function on immediately, and then grab the parameters after the fact. Here it is. I like it. We'll grab off after the evaluation the value. Why not? Or we'll do pop value. There we go. Very, very cool. Let's do 1 plus 2 times 3, and then we'll put another one on the stack, and then we'll add them together, and then yeah, we'll just do that. 13. Look at that. That's really cool. So this is just a little idea I've been toying with in my head. The real implementation should, instead of just like the reason why I had these numbers here is at any point, instead of like, this is really janky, it's because I know that there's going to be either one or two things on the stack that should match the number. But really we should be looking back as far as we need to on the stack to apply the function to it. And so long as the thing on the stack matches the parameter that we're expecting, then we apply it, and then we collapse one level down. And then you keep doing that until you can't collapse it down anymore. And you do it either way. And you can even do higher order functions with this too, because you could say, okay, this function requires a function, and if the thing on the stack happens to be a function, or the thing that you're passing in happens to be a function again, you look at the maximum number of matches that can happen, and if you see a number and you're expecting a number that will produce a number, you can evaluate that together as well. So that's a bit that is a little bit more complicated, but it really shouldn't be too difficult to implement. So I think what's really cool about this fourth idea is that you can have a very naive parser. Of course, a better parser would. I also was experimenting with, like, here there's no operator precedence happening, right? Because you're evaluating in a single pass. Like, literally as soon as you're consuming tokens, you can start evaluating. You don't even need to parse in a separate step. Like here we're parsing or tokenizing first. We're iterating over the whole string, and then we are evaluating. But you wouldn't even need to do that. You could just start reading token by token, like not even token, character by character. And your tokenizer will tell you, okay, this is now a complete token, and then as soon as you have a token, it can be evaluated. So that's an idea. The other cool thing is, so because of that, there's no operator precedence though, right? Because you're not ahead of time checking to see which one should take precedence. But then here's the idea: if you could add parentheses in there to make it evaluate in a certain order. And I think the way that you would do that is essentially when you see a set of parentheses, you essentially push a function onto the stack, right? And say, I'm going to delay evaluation until I see the end of the parentheses, and then once I see that, I'm going to evaluate everything in the middle. And I think that's how that would work, right? Maybe? Yeah. So like if you wanted 2 times 3 to take precedence, right? You would do that. You would say, okay, I'm going to put 1 on the stack. So let's see how we would want this to happen. So first we would want 1 number. Next we would see the plus. So what would end up being on the stack would be, actually here's what I want to do. I want to put the token and then what the stack will look like. So again, the token here will be plus, and then the stack will be function of number. There we go. Okay, and then we would see the parentheses, right? So we'd see a parentheses, and essentially what we want there is we basically leave the stack untouched, right? Then we see 2. There we go. I'm realizing that I need to actually kind of put the stack in parentheses here. Brackets here. Okay. So then the top of the stack we're going to put on the left side here. Right. Then we'd see the times. We would have a function. Of course, this is we're going to actually put the that will kind of indicate what function we're talking about, because at this point in the stack, when we hit this times here, we're going to have 2 functions in the stack. One that is expecting a 3, and the other that's expecting the result of the parentheses, right? And then we'll hit the 3, and then this will collapse this one down to a number, right? So we've applied this multiplication to the 2 and the 3, and then, and then we get the result of that, which will be 6, right? And then we see the closing parentheses, and we do that 6 plus the 1, so then we do 7, and then that's it. We're done with our stack. So essentially a parenthesis should just like leave it untouched, leave the stack as is, and the closing parentheses should, what should the closing parentheses do? You should say okay, so at this point we took the when we took the 3, we have 6 number. Oh, closing parentheses essentially says take the top. Oh, it essentially says like take the stack and try and evaluate it with the next bit. I don't know. I kind of want to, let's go a little further and see if we can implement that parentheses there. So we'll just say the simple one is case of parentheses, and in this case I'm going to remember a break there. I think we don't want to do anything, right? I think you just want to leave it untouched. The one that's a little bit more difficult is the case of closing parentheses. In this case, you want to, if stack 0 type is equal to number, then, so I'm going to just bake it in right now, and we're just going to say stack dot unshift, take the first one. Okay, again, gotta stick this, stick that in a value. Okay, so take the first one on the stack, and then take the second one, we'll say top okay, we'll take the top value, but then we'll do stack dot shift dot value top dot value type number, and of course we're gonna actually have to do the real. Okay, so it didn't like that, but I also don't have spaces between my infix there. Okay. Undefined is not an object. Line 20. So what's going on here? Top will shift it by 1. Should give me that 6, right? The next bit should give me the value that's a function, and I'm calling that with top dot value. So let's real quickly, before we even do anything here, figure out what the stack looks like. Interesting. The first time it hits this, interesting. Okay. So this doesn't just leave it there, right? Because as soon as it hits this 2, it's going to attempt to apply that to this guy. But you can't let it, essentially. You gotta say, don't do that. So I think essentially you want to put onto the stack a function that's an ID, right? You want an ID function which takes type parameter t and returns t. Right? I think that's what you want. So we're going to shift, we're going to put a value of a function that just returns itself, it's an identity function. And yeah, sure, we'll just leave it as number because we know that the next thing's going to be a number, right? Hey, look at that. That's exactly correct. Okay. Look at that. So that's the expected result, 7. So now now we have the ability to use parentheses to put in ordering of things, right? So if you also then wanted, let's say inside of here you did 2 plus 2 times 3 is 6, plus 2 is 8, plus 1 is 9. Save it. 9. Excellent. And then if we remove the parentheses, what would it be instead? It would be 1 plus 2 plus 2 would be 5 times 3 would be 15. There it is, 15. That's really neat. Okay. So I guess next time the idea is we'll make this work correctly, where instead of it just being, because we really hard coded and it just works for numbers, doesn't work for anything else, and we really only hard coded it in like the first couple cases of things. We don't have the ability to do higher order functions and things like that. So that will be the next time we look at this, although probably the next stream I do will be back to doing some exorcism problems, so we'll see. Alright, see y'all.